We're trying to build a more complex automation than we ever have before. There is a chance that you hit a plateau at some point that you won't be able to get past without a completely new approach. You end up in this infinite tree of like different decisions that you have to all map into one cohesive thing. There's a certain element of this has to work, as there always is with startups.
Hi, I'm Brett Gibson, and welcome to HiBit, a new podcast where we do deep dives on the art of problem solving with engineers and technical experts from our community of early stage startups. In today's episode, we're sitting down with Gautam Bose, founder and CTO of Automat, a company that's building a platform to automate repetitive tasks like documentation, invoicing, notes, and standardized emails. The details of engineering problems fascinate me, but I'm just as interested in how the best engineers I know think, how they zoom in on which details matter the most, and then use that focus to navigate to elegant solutions. Join me on this journey as we discuss thorny engineering problems with my guests and get into the weeds about how they solve them. Hey Gautam, thanks a lot for joining me today.
Yeah, happy to be here. Good to see you, Brett.
Awesome. Well, maybe we can start off by just telling everybody what Automat does.
Automat makes building workflows as easy as sending us a video of the process that you want to automate.
Great. And how did you decide to build that?
My co-founder and I really got started trying to apply LLMs to everyday tasks that we had faced as engineers and designers. And we realized that as we started to build these automations, it was actually part of this much broader industry called robotic process automation that has been around for a long time. And it's been used by businesses to save hundreds of millions of dollars. We realized that we could bring a new wave of RPA to market that was a lot more flexible and solved a lot of the challenges that had existed in the industry before.
And then, so when you went to do that, you had this insight that we'll start with video and then translate that somehow to LLM.
Yeah, I mean, we really started with kind of the North Star user experience that we would want to have if we were trying to optimize some part of our business. For a lot of folks that are less technical, even a no-code tool can still get really complex when you're talking about a workflow that is 200 or 300 steps long. And that's information that folks can keep in their heads, but it's really hard for them to put a pen to paper and actually build that out in any software. The idea of just screen recording what you want to accomplish and then just sending that off and then getting an automation built based off of that spec alone was really compelling to us.
It sounds like there's maybe a few difficult things going on. There's a bunch of cutting edge technologies in both, all the way from computer vision to getting LLMs to plan and do things. But how would you describe what's particularly hard about building this?
A key thing to say is that there's no magic in this. We are very clear that we have human integrators in the loop that are actually fixing any output mistakes in the LLM. The planning on a even state-of-the-art models is not going to be perfect for some of the complexity of the workflows that we want to automate. And so we want to back these automations 100%. And so we have human integrators in the loop. And the challenge becomes how do we get humans and the AIs to collaboratively build this thing and then execute it reliably at scale, and also have clear visibility for customers, what is happening when these automations are running, what is the receipt that I can see, when I click run, how do I know that this will actually complete successfully? With the automations, partial runs can often be catastrophic because you have this malformed data entered in a database essentially. So there's just so many different complexities to making this reliable and robust at scale.
And you were telling me about some common ways to think about working with LLMs and the problems that arise. Maybe you can talk a little bit about that.
Yeah, so within robotic process automation, any UI-based automation really, each step depends on the subsequent step being executed successfully. So it's almost like this Swiss cheese analogy from aviation where, each time you make a decision on a flight, that's a slice of Swiss cheese and there's, different holes. And if you keep assembling those slices and then there's one hole that goes all the way through, you're gonna, crash or have an incident or something like that. So for us, we have to really test the end-to-end system to make sure that small inconsistencies in early steps aren't causing later steps to fail, or if the content of the surface that we're automating on, the website or the Windows application, is drifting slightly, like if elements are changing, it's important for us to like keep track of that because that has like a much bigger effect down the road of the automation. Even if like the first step is working successfully, the second step might like have a slight error, and then like by the end, you've clicked completely the wrong buttons. You're in a completely different part of the interface than that you want it to be like originally.
That's interesting because it seems, even though you're not using the LLM at runtime, some of the problem shape is similar in RPA. You know, there's similar. It feels like you need to bring a similar mentality to solving RPA problems as you do to using LLMs generally.
I think the big thing with RPA is like you're operating on this program that you don't really control, and so like there are always things that will happen outside of like the specification. I think like a common saying from like the old world of RPA is like it's not what your user tells you to automate that's going to cause you a problem, it's what they leave out.
Yeah.
We just have to be like very rigorous in terms of the testing procedure, making sure that over the course of 100 runs something isn't going to break, where even if like it might run once successfully. And I think there's kind of like a parallel to developing with LLMs, because like the first step, I think for most of us when we have an idea, it's like go try it out, go on ChatGPT, go on like whatever you want and like try it out. And stuff that like may seem like it's working in 1 or 2 runs actually may fall apart if you do it 1,000 times or 100,000 times.
Even though the user may not think of it, it's an interestingly adversarial environment where you're coding against a lot of things you don't control and have to deal with how they change and react. I remember when early on in my career, I was building a lot of bookmarklets before browser extensions were widely available. And, you know, it was always this bane of like, what is the CSS on this page? And like, you know, if I change something, is it all gonna explode up? And the quality of the coding on the underlying website is like a big deal.
We're trying to like stay above that as much as possible, like by using computer vision and not like necessarily going into the actual HTML of the website, like as much as possible. Yeah, you're just really like have to create all of these systems to kind of catch like the most common issues with websites. And like the classic ones they have so many systems to deal with this, and like, you know, kind of the old world of RPA, like stuff like loading, detection, modals is like probably the like number one thing that people like have issues with on this stuff.
Especially with all like the European cookie regulations.
Yeah, oh my God, the cookie banners. You would not believe some of the cookie banners I have to deal with. Like, yeah, it's not even like, there's like one world of like, okay, like, are we detecting the right element? Are we clicking on that? But then there's like a whole second thing of like, is the page actually gonna like respond to that click? Or is it just like so broken that the click handler like is just like takes 30 seconds to load in even once the like rest of the content is loaded? And like, that's why we still like have a human in the loop to like catch stuff like that, and to be able to like, takes 2 seconds for me to just say like, okay, dismiss this modal, like until like we really have the full like end-to-end system to detect like everything, every action, like is it fully completed successfully? Like is the underlying data representation in the page reflecting what we've done? Then we can like really roll this out to like anyone that wants to make RPA on their own. But until that point, like I think it's important that we just have like our integrators making sure that these like go off without a hitch for our customers.
It's interesting to think that as you make effort to be able to handle any environment, you know, what's going to happen over time? Is it going to be more abstracted from users who don't have to use as much, and then thus easier for you to use with more machine interfaces? Or is it just going to be harder because, you know, no one's maintaining these things and it's assumed that AI can figure them out?
Yeah, I think it's hard to say. I think that there'll be like a divergence. I think a lot of sites, a lot of like tools will kind of go into the unmaintained, but like, you know, we have these whole new layer of software that sits on top of that. And then I think there will be a class of websites that are highly adversarial, like a class of software that is really adversarial to this type of work, and will like have a next generation of human liveliness scores and stuff to like detect who is on that website. And yeah, that's definitely like an interesting arms race that I see like coming up as people become a lot more aware of like different technologies, like using their website and crawling. AI is like crawling on your website and stuff like that.
Because in some ways you can kind of count on legacy and bit rot, you know, being endemic in the web forever, right?
So. Yeah, and like, I mean, to be honest, like that's already becoming like a bigger and bigger portion of our business. And it's not in websites right now, it's in like Windows software. And so like that for ages has had that problem.
Yeah.
There are some like ways that people have tried to to mitigate that. But RPA like is really a huge part of bringing like some of these legacy Windows applications that no one wants to work on like into some sort of cohesive like modern API that people can actually work with.
Yeah, you have all these systems that are sunk costs that can't be upgraded.
Yeah.
The other thing you're talking about is how sometimes there's a bit of a red herring with LLMs, and like you can advance things and not really know if you just got lucky or it's actually working the way you want it to.
The worst thing that we could see is like a single run has completed successfully. You know, that is like, okay, there's no way to know based on that, like, is it working or is it not? Like when we first started working with this, we were like, oh, like we got this like one run, let's like get our screen recording. And like, now that we're actually deploying these for customers and like maintaining them and making sure that they're up and running, we realized that like, okay, it has to run successfully like 200 or 300 times for like a small workflow and like probably a couple thousand to tens of thousands of times for like more complex workflows before we're really like, okay, this is actually like gonna meet the accuracy that we need. And that's just like out of the gate, right? Like we also on an ongoing basis keep up and make sure that the automations are still running. So you can get into the hot hand fallacy a bit where like, probably you've seen this on, if you've tried like with ChatGPT, like you could get it to answer a question right, but then I rerun it and like it answers wrong. Or like maybe you get 2 in a row or 3 in a row or 10 in a row and you're like, okay, like I think I've really got something here. But to know whether that will actually work at scale is like, yeah, it's really hard to tell without really testing a ton of like different inferences and analyzing that output.
Yeah, it's wild. It's like, it's probabilistic all the way down, which is kind of not always naturally intuitive for humans.
You know, Lucas and I, my co-founder and I, like got our start with like image classifiers, and those like are like somewhat deterministic, like with at least like the ones that we were working with. And so it's definitely like even within the ML space, a pretty new thing, but we built a lot of tooling to actually help us with this. And I'm pretty confident that like OpenAI and Google will like release even more tools to actually like help us analyze the output and understand what like the performance will be like in production, not just in my like playground or whatever view.
Does working on all these like deeply probabilistic systems give you like a zen outside of
It makes me suspicious, I think. That's my biggest thing is I'm just way more suspicious. And like any demo that I see, like, I don't know, I'm just highly suspicious nowadays, I think. When we work with our customers, like we have like a demo video that we'll send them and we'll also like try and send them like, here's the actual like statistics of the run rate in our testing. And like, this is one slice of this like whole thing. And you're gonna run this hundreds of thousands of times. So like, here's what you should expect.
Yeah, and you know, I've talked to a few people about how working with LLMs can often be a fundamentally different type of engineering because they are not deterministic systems. And so maybe you can talk a little bit more about what have you had to do to get reliability when they're core to your product?
We have our LLMs generate code that is actually executed at runtime, and that lets us like inspect the output in a very deterministic way. Whenever novel situations arise, as they inevitably do within websites or other software, we are like regenerating code like in that instance. But for the most part, like we do have this kind of deterministic build process where we can inspect the output before that makes its way into production. And so we're not just letting AI agents run loose in our customer systems, and we are like very carefully applying them in points when we need them and like making sure that the output is good before actually like deploying that to a customer.
Yeah, that makes a lot of sense. So you're able to have safeguards because they're not just running wild at runtime, and you only interact with them when you create the automation or have to update the automation.
Exactly. Yeah, we kind of view it as like a way to supercharge what an RPA integrator would have done in the past.
And so that means the automations themselves don't have decision trees, I guess, that they have to react, or that's just all capturable?
We essentially like take the video that our customers give us and turn that into a text representation of what their task is. And that text representation is like a tree-based system. So any like business logic will be captured in that representation. In terms of like decisions happening while the automations are running, for the most part, if there is no like novel situations arising, then like we're just running the code that we've generated. We've almost like mapped it to this code generation problem. But then like when situations do arise, we do like allow some amount of flexibility in the automation so that we can actually like continue forward and not just get, like one of the classic things with RPA is like one button like shifts or the label changes and then the whole thing like doesn't work anymore.
There's a lot of complexities generally, but we were talking before about when you kind of ran into more complex decision trees. Maybe you can like talk a little bit about the problem that you ran into.
With our customers, like we have varying degrees of complexity within a single workflow. So some workflows are 5 steps, some are 2 steps. But then some of our customers approach us with, hundreds of pages of SOPs, standard operating procedures, and they have huge teams that are like just dedicated to like executing this SOP exactly as they've defined it. And so like for them, 3 or 4 years ago, they like were like, okay, we're going to commit to like building out the most robust SOP collection.
Before they would have been using a system that like recorded how were they previously being translating?
These were like usually written up in a Google Doc, like written by hand by folks who like designed these systems. Like order comes in, they might have an operator that like reviews it, checks certain things, and then like sends it off to the next stage.
So for an SOP, it could be a manual steps for a human to follow, or like some like previous generation of RPA.
Exactly.
And so you ended up with a customer that had a much more complicated SOP?
So we have a customer that had an SOP that basically like, they had a set of SOPs and hundreds of pages. Each SOP contained like really deep references to the other procedures that they wanted to like accomplish. So like if I'm going through, one SOP as like a human operator, right? I'll go, complete each step, and then all of a sudden it'll say like, go to like section A.2. whatever of this SOP. So there'll be like a link, and I'll click that. And then, by the time I've actually like gotten through my single SOP that I started, I'll have touched like 5 to 10 other SOPs. So when we think about automating that, there's just a ton of context that has to be like loaded in and swapped out as we like try to branch out to these other SOPs. And when we first tried to apply the techniques that worked on a few hundred steps to this like hundreds of pages of steps, everything kind of broke. Like we would jump to another SOP and like the model would instantly lose like the context that it had from the first one. And so we needed to like find a way to keep all of this in some sort of like cohesive, like text-based representation that we could then like feed to an LLM.
It's almost like an old style programming language that uses GoTo as its control flow. You're reacting like, does your SOP interpretation thing need to be Turing complete in its own right? Or
there would be like these go-to statements that I always think of. And like I had a friend in college who loved like basic programming, and like we were learning Python. He's like, there's no go-to, like what's wrong? And every time we were like implementing this kind of like subroutine idea, I was just like thinking about him.
So who was there? Like who was approaching the problem? Was the whole team, maybe set the stage in terms of like, how was everybody feeling? Were you like, oh crap, or was it?
It was myself, my co-founder, and we had one other engineer at the time. Yeah. And my co-founder and I were like, first of all, like really trying to make the SOP simpler to understand. There's a ton of like clinical context in this SOP that was really not needed to actually accomplish the task and would like throw off the model in all sorts of ways. So I had him like rewriting some sections to be like simpler to understand and like more straightforward. And meanwhile, like I'm feeding them into the model, I'm making adjustments to like the prompts, adjusting like the RAG system that we use to like pull data from the actual like customer's interface. Just planning out these steps is only like the first stage of the problem, because the next part is like actually executing those actions on the user's dashboard. So we kind of like, I had our first engineer working on the action execution part. I had my co-founder like just steeped in like knowledge about this customer, trying to like understand exactly what the SOP is getting at so he can write it to be a little more straightforward. And then like I'm trying to figure out how we can create this system that lets us jump around between different procedures without like losing the thread of the automation.
As you try to figure it out and kind of to destruct the inputs, was it clear? Like, did you know what it like how clearly was success defined? Was there a chance that you get something working and it's not, we've lost something along the way?
This kind of brings us to like another core part of testing RPA and LLMs, which is like testing it on a lot of different inputs and keeping a really like robust sandbox environment so that you can actually like break stuff and not have it impact the customer's real data. So like we had a set of about 300 like example orders that all had like something wrong with them basically. And the SOP described how to fix it and like send it and say like, okay, this has been reviewed and like checked. So we basically had to get to a certain percentage of orders with this customer that like were resolved automatically. And then the rest we had to like send a Slack message to the right channel. And so like they have a lot of stuff that they call it like escalations, right? Where it's just like send a Slack message. Thankfully, that part like is a little more straightforward now, but we had basically very clear metrics for this kind of test set that we were trying to get to. So each time we make a change, we'd start by running it on like one order, then run it on 50, and then run it on the complete test set, like as we started to understand how it was impacting the performance.
Yeah, that makes sense. It just constrained the complexity of knowing whether or not it works is an interesting problem in its own right. How did you end up cracking it, and what was the solution?
At this time, this was like right when function calling was kind of becoming like a first party like supported thing within most of like the major LLM providers. And that ended up being like the key, was to basically turn each SOP into like its own function that would have very specific arguments. And those arguments are the only context that is required to actually execute the entire thing, or like that entire section, for example. And so we would go in and like at each point where we would potentially jump to another like SOP, we would say like, okay, like at this point, we'll have like optional function to like call this subroutine that will actually then like spin up a completely new browser in parallel that like executes that and then like returns back, and then we can like continue on, down the path. So it was kind of like this exercise of like we're taking like the program that we had made to like walk through one kind of tree to like turn that into something that could run recursively in the self-contained way where we could like call it almost like a function.
Wow. And did you have to worry about it like recursing infinitely, or
that
just
is
going crazy?
Definitely. I mean, I feel like when we look at a lot of the open source agent tools like Agent GPT or Engineer GPT, that is like, as soon as the problem gets like to a certain complexity, I feel like you almost always end up with this like infinite delegation problem where it like will spin up new agents that just spin up new agents and so on. For us, like because we have a human integrator, we're like giving it clear points where it can spin up these new agents and then points where it has to either proceed to the next step or perform an action. So we're just like constraining the problem space to kind of avoid that class of problems, I guess, versus like trying to solve that head on, because like I think for our customers, like they want to guarantee that they're not like that their stuff is going to run.
And how did you, when you came upon this approach, did you know it was going to work? Or was it just, we're going to try this out and see? And then how did you ultimately know it was succeeding?
I think there's a certain element of like, this has to work, as there always is with startups, but I did not know it was gonna work at all. We were trying everything, and like when we first talked to this customer, we really thought like, oh, like this is gonna be our easiest implementation yet. They have everything documented. But it turns out like, because of how like extensive the documentation was, you can like, as I kind of said, like you end up in this infinite tree of like different decisions that you have to all map into one kind of cohesive thing. So we started like initially without a specific function calling model, and we were kind of using the standard ways to like get structured information out. And that would kind of work, but it wasn't until we had a model that was fine-tuned for like tool use that it actually started to work reliably. And we could see like, okay, like this thing has gone from like, 50-50 to like, we're starting to see like, oh, like we can do like 70%. And if we actually like improve the prompt in this way, we actually like can track that improvement. Like, and it started to really actually be like a more tractable problem at that point. I think like when we first started, it's like, we have a lot of ideas and we're never 100% sure that the choice we're making like is the right path to invest time in investigating.
It's interesting because it's a lot like designing ML systems, whereas opposed to there's less binary feedback that the thing worked or not. Like you get an insight that directionally the approach is working, and then you think, oh, I can refine.
And like there is obviously the chance that you hit a plateau at some point that like you won't be able to get past without a completely new approach. I mean, I think for us, like, when we're trying to build a more complex automation than we ever have before, I think we were a little naive in assuming that like we could do it, we could adapt to it. But sometimes that's like the only way forward, is just to like not worry necessarily about everything you could have done and just like try and focus on getting your like one idea kind of off the ground and working.
Yeah, constrain the problem and constrain on both inputs and outputs a bit. Yeah. And then just trust in your iteration.
I think that's something that like my co-founder and I both like have really come to rely on, and like it gives us the confidence, sometimes rightly, sometimes wrongly, that we can like solve anything, because like I never say like no, I say like I can look into that, and I do feel like through iteration, through like trying things, like there's always ideas on how to improve things, and it's just a matter of like the time versus the money versus like the tech that we're actually investing in, like trying to kind of align all those three things, I think.
And so at no point do you feel I need this immense breakthrough. You just need to move the ball forward, and then the problem will fix itself eventually.
Yeah, I'm pretty rarely like hoping that tomorrow, like I'll get out of the shower with the most brilliant solution and code will just flow from my fingers. Like, I don't know. I pretty much, I'm more in the like work at it every day, and like that will compound. And we learned a lot about how to manage expectations with a customer, how to sell the product to customers, how to talk about what like an error might look like. And I think like, at least from what I found, like the more that we know about how the process is going to run and where the pitfalls are, and we can like be upfront about that, like the actually like the more our customers trust us in a way. Versus like, when we started with that customer, we had only, it was our 10th customer or something. Like, so there's a lot of unknowns, and like as we go, we're just kind of continually discovering tar pits you might fall into. And I think being aware of that in the sales cycle is actually like really helpful.
Yeah, and well, there's a bit of an aspect too in the stepping back at the startup level of, it's always best to make a small group of people very happy first, but also you need to exercise the breadth of the problem. And so going out and finding a customer that was a little bit pathological in terms of the workload makes the product a lot better. Ultimately.
Definitely. Having customers that like have really high standards, but are also like willing to work with you and like understand what you need to actually like accomplish what they want is really been incredibly helpful. And like there would be no Automat without our customers, like kind of understanding that.
So what's next for Automat? What should we be looking forward to?
Coming up next, we're really excited to launch more standalone tools for users to be able to take their workflow videos and actually like turn that into their automations fully on their own. Right now, like we do have these integrators, and we work with like customers that have really large volumes of workflows or really complex workflows. But we want to like make this kind of like RPA technology not something that's just like for businesses and is something that anyone can really set up and use really simply. So yeah, keep an eye out. I think we've got some really exciting launches in the next few months. Folks will be able to go to the Automat playground, we're calling it, and be able to upload videos and then receive the automations like all within that one website. So
yeah, that's great.
Yeah.
Look forward to that. Okay, well, I really appreciate you coming by. The office has been really fun to talk about, so thanks a lot.
Yeah, this was a blast. Appreciate it, Brett.
That's it for this episode with Gautam Bose, founder and CTO of Automat. HiBit is produced by Initialized Capital. Our showrunner is Candy Chang. Our videographer and editor is Kevin Heinz. And I'm Brett Gibson. Thanks for listening.